So as you can see, this is CloudFormation under the hood. My name's Adam Thomas. This is DJ Edwards. We're both software engineers at CloudFormation. And we're going to take questions at the end. So once we're done, I'll just throw it up to the mic, and you can walk up and ask us questions for a while. And you'll get started. So you might be asking yourself, what is CloudFormation? Unfortunately, I'm going to be mean and not go over that at all. So hopefully you're advanced users of CloudFormation. There was a talk that went into some more of the basics. That was 0 to 68 of CloudFormation. Unfortunately, that's already happened, but you can get the video online. There are also some hands-on labs that you can walk up and learn about CloudFormation at your own pace. So if you don't know CloudFormation very well, I don't want you to leave. I just want you to learn what you can, go take a hands-on lab, and then apply what you learned today to your knowledge of CloudFormation. So what are we going to go over? I'm going to spend most of the talk on custom resources. So what they are, what you can do with them, and how you can write one. And since DJ and I work on CFN and init, we're going to work some content in at the end about some new things that you might not know about with CFN and init. So let's jump into custom resources. And so we've identified basically 4 main things that CloudFormation can do for you, custom resources can do for you. You can add new resources, which you can kind of guess from the name. You can also interact with the CloudFormation workflow, the create, update, and delete workflows. You can get dynamic data into a stack from sources other than parameters. And you can extend the capabilities of existing resources that CloudFormation can create for you today. So what is a custom resource? It's an SNS topic, but that on its own is not very useful to you. So you hook that SNS topic up to a service that can read JSON messages that CloudFormation will send to your service. You manage the lifecycle of a resource and then send a JSON response back, and that's how you integrate into CloudFormation. So if we look at a little snippet of what a custom resource might look like, you can see it has a type of custom : my custom resource. So you can put whatever you want after those 2 colons. And then the properties, there's only one required property, and that's the service token. And you can see the format today as an SNS topic ARN. So that's the topic ARN, which will receive the messages from CloudFormation. And then the properties can be whatever you want. You can name them whatever you want. You can have as many of them as can fit in the template, and it can be of any JSON structure. And we'll just pass that on down to the custom resource implementation to do with what you want. So as long as they're valid JSON, it can be anything. We don't validate them. So let's jump into the first type of custom resource, the adding a new resource. So a new resource is really anything that you can create, update, and delete. You might be thinking, well, you already do EC2 instances, auto-scaling groups, load balancers. What really more do I need you to add? And I would encourage you to think outside the box and think about software resources, the schema for your database, a Docker container. If you're running an Apache server in your data center, adding an entry to a configuration file pointing at your CloudFormation stack is certainly a resource. So let's meet a user of custom resources. And this is Steve. Steve loves relational databases. If you asked him what version his application is, he would tell you the version of his schema before he'd tell you the version of anything else. But Steve doesn't want to run SQL scripts by hand. He finds it very dangerous. He wants a more controlled environment for custom resources, or for updating his schema. So he thinks the template, since he loves CloudFormation, should define his schema explicitly. When he wants to update his schema, he should just call update stack. And when something fails, either in his schema update or in a downstream resource, the schema should roll back to the last known good state. And so Steve's solution is going to be to write a custom resource using Liquibase. Liquibase is an open source schema refactoring tool. There are a lot of tools like that out there. This just happens to be the one that Steve knows best. Lucky for him, Liquibase supports JSON formatting out of the box. So he can inline JSON schema into his template and pass it directly to Liquibase. So this is an abridged version of what the template will look like. You see we have the custom database schema. I've omitted a bunch of other stuff to focus on this part, the database changelog. That's the name of the core object in a Liquibase schema document. And so a database changelog has a list of change sets that has a list of changes And so you can see here that there's one, the first change set is going to create a table with the name of person and then add some columns. So let's take a look at this live. All right, and since I don't want to make you guys wait for an RDS database to create, I've already created one for us, the schema demo stack. If we take a look at what the template looks like, this is a little bit more of the syntax. So you can see that it's describing what the SQL schema will look like. And so I have an ID column and I have a fruit column. And what I'd like to do is add another column. And so I add another change set to my template, and I just add a vegetables column because I couldn't think of anything else. So let's go ahead and call update stack, just like you would normally. With my template. All right, and now it's going to kick off a CloudFormation workflow. And I'm going to pull up the schema right here. And so you can see I have two columns in my example table, ID and fruit. And so once we hit update in progress in the MyDB schema, now my code is running. That's going to call Liquibase. And so the time this spends in update in progress is largely going to be the time Liquibase spends running. So we'll just wait for that to complete. And now we went to update complete on the stack. So I should be able to, if everything works correctly, have a third column called vegetables. So as you can see, a simple update stack with some JSON formatting updated the schema of my database. So let's look at the second type of custom resource, which is a resource that interacts with the CloudFormation workflows that create, update, and delete workflows. There's a resource in the CloudFormation library today called wait condition that already does this, and it interacts with the create workflow. So if you're installing software on an EC2 instance, you use a wait condition to wait until that software is done. And then when the software is done installing, you signal the wait condition, and the create workflow continues. If your software fails, you signal the wait condition, and you roll that back. A custom resource can do the exact same thing, but you can extend it to the other workflows to provide those hooks for you. So you can react to the workflow state, you can make the workflow wait until you do something else, and you can fail the workflow if something's not right. So let's meet Frank. Frank is a person who loves to analyze data on EBS, and he uses CloudFormation's snapshot on delete feature to save his results. So he's got an EBS volume that has a bunch of data on it. He runs some analysis, saves the analysis results back to EBS, and then he deletes the stack, and the snapshot has his results on it. So when he creates that snapshot, he wants it to be consistent. He wants CloudFormation to be able to cleanly unmount it, take a snapshot, and delete the volume. So you might be thinking, why is this hard? Typically, people put a mount statement in their user data scripts. And the user data script isn't run by CloudFormation. That's run by the EC2 instance. So CloudFormation doesn't know that that mount has occurred. What you need to happen is for that mount to be unmounted before you try to detach the volume. Unfortunately, EC2 is going to be deleted after we go ahead and try to detach that volume. So what the custom resource lets you do is to pull that mounting and dismounting logic up into the CloudFormation stack. So CloudFormation knows to dismount the volume before it tries to detach it. So what's Frank going to do? He's actually going to write his custom resource in Bash. And it's going to run directly on the instance that has his EBS volume mounted. So he doesn't need to run an entire service dedicated to just mounting and unmounting volumes. No more hardware required. So on create and update, he's going to mount the drive. And on delete, he's going to unmount it. So this is an abridged version of what his template will look like. The first part is a volume attachment. And that's built into CloudFormation today. So that takes an EBS volume and attaches it to an EC2 instance. The second part is his custom resource. You can see it's called the volume mount. He specifies the same device that he's going to use in the volume attachment, devxvdh, and then he tells it to mount to /mount/analysis. So on create, it'll do this mount, and on delete, it'll unmount it. So let's take a look at this live. So I'm on an EC2 instance now, and you can see that I have run df-h to show dev xvdh mounted on mount analysis. And if I look in here, I've got the 3 bash scripts, and then I just log out what happens when those bash scripts run. Let's go ahead and take a look at this template. So you can see up here, I'm not going to scroll all the way up because there's a lot of JSON I'm sure you guys don't want to look at. There's an EC2 volume, and there's a volume attachment, like I said. And then we have this volume mount. And you can see here I've done 2 things with depends on. I have the volume attachment, so I want the EBS volume to be attached to the EC2 instance before I try to mount it. And I have a wait condition that is actually waiting until the custom resource is ready to process on the instance this custom resource definition, since the custom resource is actually running on the same box. And so to simulate a delete, I don't want to try to delete a stack while we're watching because it'll end up terminating the EC2 instance, and that demo will not go very well. I'm going to actually just remove the mount. And so what that's going to do when I call update stack, CloudFormation will see that that mount no longer exists, and it'll simply call delete on it. So if I go over to here, call update stack. All right. And so now I'll wait for the workflow to kick off. I'll go back to the instance, and you can see the delete script while we're waiting that to work off. There's not a lot to it. It all fits on this one page. Basically, I'm checking to see if the mount point is there in the properties, and if unmount succeeds, I send back success. Otherwise, I send back failure. And you can see now there's a delete log here where there wasn't one before, which means delete ran. And you can see I just run umount on /mount/analysis. If I look at df-h, it's not mounted anymore. And the CloudFormation stack has gone to update complete, where it ran delete on the volume mount, as you can see on that right there. All right, now I'm going to turn it over to DJ, who's going to take you through the remaining custom resources and how to build one for yourself. There you go.
Okay, so what we're going to do is okay. So what I'm going to talk about is the third type, which is getting dynamic data into your stacks. And traditionally today, there's kind of 2 ways that you do this. The first is the parameters, which kind of allow you to get free-form user input. You can constrain on regular expressions or other things at a stack-by-stack basis. And then mappings is another way, which is a little bit more static, but you can react to dynamic parameters or other values of the template to figure out things like the appropriate AMI ID for your region, the type of architecture you want to build on, and those kind of things. So what custom resources really let you do is allows you to kind of centralize your selection logic. Basically, the data that you want to inject to your stacks while they're building, you can move that logic somewhere else and apply it to all stacks that you create. And the great thing about this is you can do those lookups for that data in S3, DynamoDB, RDS. You could call out to other AWS APIs, or virtually any third-party data store or service that you might be already running today. So it really lets you interact with things that you might already have. So let's jump right into kind of a customer example. And let's meet Bill. Bill is the head of operations for a large tech firm. And he manages a wide range of services. But he needs to ensure that they're always running on a fully validated and tested AMI. And so the pinnacle kind of his career is he's been managing this Excel spreadsheet for years, and that's how he tracks his AMIs. And he's very, very proud of this, but it's become very difficult for him to maintain, and it's not easy for him to get things out. So what does Bill need? He needs to be able to push out his AMIs in a central way. So when he makes a change to an AMI for a security update, something like that, he needs a way to very easily let all the services pick that up when they do their updates or their next deployment. And he also doesn't want to have to edit all these templates that he's created over the years, which is what he has to do today. And one of the key things that he'd really like to do is to be able to audit what AMIs are running, where, when. So if there's a security event or they need to do some sort of log dive, things like that, he can very easily figure out what stacks are running it, who's running them, when they were running them, so he can pull the information that he needs. So what is Bill's solution? So Bill's going to create a manifest file. He's going to generate this from his Excel. In his case, he's familiar with JSON since he does CloudFormation. So he's basically going to export his Excel spreadsheet into a file that he can upload to S3 and version it as he needs. And then he's going to create a simple Python script that's going to look up his AMI IDs out of this manifest file based on things such as the region, the operating system, the architecture, or the version of the operating system that he wants to run. So let's jump in and look at what this might kind of look like. So at the top, we kind of have our custom resource. And this is the part that he's implementing. And you can see that he's asking for an Ubuntu image 1304 on a 64-bit architecture. And one of the things that's great about this is when he looks at his template now, he's not looking at it in AMI ID. He's looking at exactly what he wants to run. So his template's now giving him more information about what the template's actually using. And then to get that into, say, an EC2 instance, he can actually just ref his custom resource like he would any other resource. In his case, he has it return the AMI ID for him. So let's jump right into a small little demo. And so we come over here. And what we can see is he's defined two custom AMI lookups here. His first one, he's looking up for Ubuntu. And what you can see is I've actually excluded the version. And he's coded this up in such a way that if he doesn't specify a version, that'll just pull the latest version of Ubuntu that is approved at his company. And then we also do a Windows instance down here. He's being a little more specific, saying that I need Windows 2008 for this. And so it's actually pretty straightforward. You can, and he can look that up. So if we just jump over, to his example manifest to kind of give you an idea of what this might look like, and it's not necessarily the prettiest thing. But you can see he's come up with his structure where he kind of defines his operating system, breaks it down, and then provides different options. And so you would usually see this actually in all of your templates. You do something like this in your mapping sections. But he's able to centralize this for himself, do it once, and then use it in his templates in a nice way. But this part isn't really kind of, the pretty part about this. The part that really kind of wins it over for him is his audit table. And so if we jump over to his DynamoDB table, what we can see is, I've run a couple stacks to kind of get a little seed data in here, is that it's actually putting entries. So he can come over to his DynamoDB table. He could build a console if he'd like, where he can very quickly audit and see who's using, which AMIs, where they're using them, when they were created, when they were deleted. And that really allows him to figure out who he needs to get in contact with if there's a security vulnerability in some of their software and they need to roll out an update. He can very quickly find that information. So it gives him a lot more insight than his Excel spreadsheet that he's been managing for years. So let's move on to the fourth kind of example. And this is one of the more complicated ones. This is extending the capabilities of an existing resource. And so when you look at CloudFormation today, it's really concerned about the create, update, and delete workflows of the resources. However, certain services and resources actually have a life cycle that exists outside of these. And that's something that CloudFormation doesn't deal with today. And so there's no place to put that type of logic and encapsulate your business logic in the template. And this is where the custom resources can kind of come in and help. So let's jump in and meet Tom. Tom manages a fleet of virtual desktops in AWS. He likes to use autoscaling because that allows him to keep a consistent fleet size to make sure that his users will always have a desktop that they can connect into. And he uses VNC to connect to their virtual desktops. So what are kind of his requirements? Tom needs his servers to be easy to remember and get into. So he's come up with a really, really clever Simpsons naming scheme for his host. So his end users don't need to remember the dynamic names that come up with the EC2 instances. They can just remember that they need to log into Homer. And when he needs to take a server out for maintenance or to upgrade it to a larger size or downgrade it to a different size depending on his user needs, he needs those names to be recycled so that people don't have to know 150 Simpsons characters that can remember a couple and always get into a box somewhere. So what's his solution? He's written a Python script that's going to respond to autoscaling notifications. And this may be a feature of autoscaling that you're not familiar with, but it's actually kind of a neat little one. What it is when you create your autoscaling group, you can tell it that you're interested in certain events that happen on it, such as an instance being terminated or an instance coming into service. And what it'll do is it'll publish that notification to an SNS topic of your choice. And that's what Tom has done. And he's going to take those notifications and manage the Route 53 entries for the instances as they come in and out. And he's going to use a DynamoDB table to keep track of which names have been used, which ones are available, and by who. So let's look at what this might look like in your JSON. So we'll start off with his DNS processor here, which is the custom resource. And you can see it has a hosted zone ID. That's a Route 53 concept, and that's basically your domain name. But the kind of interesting part here is his DNS pattern. And this is where he's defining what he wants his host names to look like. And since this is dynamic, he can't just put them in. So what he's done is he's leveraged a mustache type style syntax. And if you can follow this a little bit, basically what he's doing is creating names like homer.uswest2.tomsdomain.com. So then when he defines his autoscaling group, he starts off by creating that notification configuration we were talking about. And he's saying he wants to see EC2 instance launches and EC2 instance terminations. Now the topic ARN, you can see he's actually he's doing a get at on his custom resource. So topic is one of the data pieces that his custom resource is returning and providing to his template. Now this is the part here, the tag. So he's actually going to tag his autoscaling group. And the reason he needs to do this and why these are a little bit more complicated to work with is because he's working outside of the context of CloudFormation. So when one of these events gets triggered, it's not actually part of a CloudFormation resource. So he needs to actually have a little bit of context when he gets that notification from autoscaling, like which DNS records he needs to actually modify. So what he's doing is he's tagging this with the physical resource ID of his DNS processor so he can look up those notifications and know which one he needs to actually modify. So let's just jump into a simple example. Well, somewhat simple. And what we'll do is we're going to look at the Route 53 console. And so I've already spun this up. And so he has two instances that are active, Abe and Artie. But you can see, oops, he forgot to put his region in there. So what we're going to do is we'll go over to CloudFormation, and we're going to do an update stack on this. And not to bore you with looking at the template, because it's not that interesting. We're going to update it so that it has that region in there. And this will let us kind of see part of the flow that we want to talk about with CloudFormation. If I can get there fast enough, hopefully. So if we watch our Route 53, I'm going to keep refreshing this because I don't want to miss it. But what we're going to see happen, hopefully, is now he has 4 DNS entries. So you may be asking yourself, why are there 4? At this point, what's happened is CloudFormation has recognized that there's an update to my resource. So it sent me the update request saying, hey, here's the new domains that I want you to register, or well, the new instances I want you to register. And what's happening is all your update should be responsible for is doing the changes that you need. And so in my case, it's just creating the new Route 53 entries. And what I'm going to respond back with is a new physical resource ID. When you give that new physical resource ID, CloudFormation recognizes and says, hey, you've created a new resource. You haven't updated the existing one, and we call this a replacement update. So it's a two-phase. So once you say that it's update complete, CloudFormation is going to issue a second event to tell you to delete the old one. And what that allows you to do is, one, keep the existing stack and resources in place in case something goes wrong. Rollback becomes very, very easy. It's basically no work. You just delete what you did during the update that failed. What it also lets you do is keep things available. In this case, a person could continue using the old domain until the new ones are in place. And you'll see that with many resources within CloudFormation and a technique that we use to kind of give you that availability. So we recommend you do that when it makes sense for your resources. And so if I just refresh this again, you'll see that it's cleaned up the old ones through that delete workflow, and only the new ones with the regions in them are actually registered. So we'll switch back here to our presentation. And so now that we've kind of gone through and shown you some examples of what you could do with custom resources, you might be wondering, well, how do I actually start building them? And the core thing that you'll need to do is you need to write the code that can respond to your create, update, and delete events. And then you also potentially will need to write the code to respond to the notifications getting published to this SNS topic. We strongly recommend that you attach an SQS queue to the SNS topic. You can also have those posted back, but the SQS queue kind of provides you some fault tolerance. It means your backend isn't tied directly to the SNS topic and things like that, so it makes it a little bit easier for you to update or bring things out of service, and your messages will just queue up, and when your backend comes back up, it can start processing messages and nothing's really lost. So let's kind of look at a little diagram and a workflow of what's kind of happening. And so the first step that's going to happen is CloudFormation is going to start building your custom resource. And this is something you're used to today. And when it does that, CloudFormation is going to send that create notification to your custom resource. Hopefully, your custom resource is going to create that resource, and it returns a JSON message back to CloudFormation telling it the status and any data that you want to provide. CloudFormation is going to process that JSON message, and it's going to store that data so it can be used later. And then it's going to continue on the workflow and create any more resources that depend on your resource or come after. And what it's going to provide is those other resources can now actually get at any of that data that you returned through getAts and refs. And so that's kind of your basic flow. So from an architecture standpoint, what does a custom resource kind of look like? And we'll start off over here kind of on your left-hand side with the AWS CloudFormation, where it's going to create that custom resource. It issues that notification to your custom resource topic. And as we recommend, it immediately dumps that into an SQS queue. You could change this out to meet your needs however you want to architect this. But this kind of keeps it simple and a little more reliable. And then you have your custom resource implementation that will be sitting there polling your SQS queue. When a message comes in, it's going to start building whatever that resource is or deleting it, whatever the step is. Once it's complete, it's going to just send that back to CloudFormation. So it's actually a pretty simple workflow to kind of follow. But you might be asking, you work in an enterprise environment, we run everything in a VPC. Can I do this inside a VPC? And you absolutely can. And it doesn't become much more complicated. The first flow is pretty much the same, where it's going to get published to the SNS topic. It goes to your SQS queue. Then your custom resource implementation will pull the SQS. And that's however you do that today. So however from your VPC, whether you do that through a NAT, however you talk to your AWS services today, you just follow that exact same thing. So you pull SQS, you get your message. You can go back through your VPN if you need to contact something internal to your network. So if you're actually building some type of resource that is contained within your company that's not public, you can certainly do that through a VPN, so you can build up or contact services that you want. Once it's complete, you just send it back to CloudFormation in the same way that you were talking to your SQS queue. It really doesn't become any more complicated. So now we've kind of looked at that. What kind of defines a good resource? And one of the keys is that you want your resource to be idempotent. If you're not familiar with what this means, basically what it means is per one unique request, regardless of the number of times that your service sees it, you should be responding with the same result. It's actually really important because sometimes there may be network blips, a message might be resent. So it's important that you build your service in such a way that you can handle that and respond, so you're not creating multiple resources for your users. Another big key is you want your resource to be immediately available when you say you're complete. So when you send that create complete back to CloudFormation, you want to ensure that your resource is actually ready for use. You don't want to send the create complete but still have a background task, still processing and creating the rest of your resources. It can be tempting to say, I want to get this back and my stack moving very quickly. But if you have other resources that depend on that resource being created, you're going to get some very strange behaviors where they may call out to try and get something, but the resource isn't complete. So you really want to make sure that when you send back your status results, that you are actually in the state that you're saying you're in. Another big thing is is you want to make sure your resources can be deleted pretty much from any state that you could imagine that it could get into. So like, say there's an update failure or a delete failure, you really don't want your customers or your stacks to be stuck because your custom resource can't delete from a specific state. So you want to make sure that regardless of the state that the resource is in, when you get that delete message from CloudFormation, that you're able to handle that and clean up the resources. And this one's is more of a guidance, the last one from us. So it's not really going to break anything, but it makes your life a lot easier, is when you build a custom resource, try and focus your custom resource on one specific piece of functionality. It's very easy to say, hey, this custom resource, I can encapsulate a whole bunch of stuff, and it looks really great in your template. It makes it a lot easier to write your template because you just put in this one custom resource, and it does 50 things for you. But we strongly, strongly recommend don't do that because it becomes very, very difficult during the update workflows when you need to actually get your dependencies right, get the ordering right. Leave that to CloudFormation and just create multiple custom resources and do small pieces one at a time. And if you're looking for an example of this in CloudFormation, because this is a lesson learned for us as well, is Elastic Load Balancer support embedded policies, which is really nice from a customer's perspective. But custom policies can actually depend on each other. And so by embedding it, there's actually no way to actually define that reference between the two. And so there's actually two ways you can do custom policies. And so we strongly recommend that you just keep it to one piece of functionality and don't try and embed multiple resources within one custom resource. Just break them out into two and let CloudFormation that can handle the dependencies between them, and you just need to focus on individual pieces of code. So we've kind of been saying it's pretty simple to do this, but there are a lot of moving pieces. And so what we've actually done is we've created something we call AWS CloudFormation Resource Bridge. And this is a cross-platform hook-based daemon that you can leverage today that handles most of the architecture for you. So it's going to handle getting the messages off your SQS queue and then posting your results back to CloudFormation. So it handles that whole piece of it. And all you need to do is apply the scripts to do the create, update, and delete. You can write them in whatever language you like, however you want to do that. So it lets you kind of just focus on your core business logic and not worrying about polling the SQS queue or trying to get your data back to CloudFormation. We've released this under open source under the Apache 2 license. So you can install or fork it off of GitHub. So jump out there and get it. Also, all the example code that you've seen today, we've also put out on GitHub for you. And anybody that's worked with CloudFormation templates, you know that stealing from someone else's template is the best way to create your own templates. And these are no different from that. So go out there, look at the examples, use them as your base, steal stuff from them, and just build some really great custom resources. And so I'm going to turn it back over to Adam to talk a little bit about CF Init, since we kind of promised we'd do that.
All right, thanks, DJ. So CF Init, if you've used CloudFormation for any period of time, something you've interacted with. If you've used sample templates, that's what we use to install the software that runs on them, like WordPress. So you can download files, start services, and install packages on EC2 instances that CloudFormation has spun up for you. And it works really on any platform that can support Python 2. So Windows and Linux specifically is what we distribute it on. So we noticed a lot of people put configuration files in their CloudFormation templates. And the only way to stitch together the static part of your configuration file with the pieces you need to pull from the other resources in your template is with the join function. And join can get really ugly really fast. We also noticed that configuration files have a lot of boilerplate in them. So what we decided to do is to add mustache support to CF Init files. So you simply add a key called context, and CF Init will automatically process it as a template. So let's take a look at an example of a WordPress configuration as you'd find it in a CloudFormation template. So this is the first page of the WordPress configuration. It's stuck together with join. And there are basically 4 fields that it's pulling from the rest of the template: the database name, user, password, and the host. The rest of it, and there are 2 more pages of it, is just a bunch of stuff you're sticking together with the join function. So it really makes your template ugly. So if you use the mustache feature, you can turn it into this. So we have a file that we're going to download from GitHub that is a mustache template. So since you're pulling it from GitHub, you can version it just like you would version your template, and you can give it an explicit revision so you know exactly what's going onto the box. And then we supply the context. So now DB endpoint, DB name, DB user, and DB password will become variables exposed to Mustache. So you can just insert those into the template, and CloudFormation will put them in at runtime. And you can use a lot more of the features of Mustache as well. You can do embedded properties, you can do lists and iterate over them. Most of the things you do with Mustache, you can do with this as well. A big request we've gotten a lot for CloudFormation is to support IAM roles. And the most interesting part of role support was downloading files from S3 using CFN init. And so it supports it today. It's actually supported it for some time. But when you're downloading a secured file from S3, don't just think about it as I'm going to download my war file that I'm running, like your proprietary business logic. You can also store non-AWS credentials in it, like your database username and password, service endpoints that you don't want people to know about necessarily, or like if you want to enable or disable features at runtime that are already in your code. And obviously configuration files as well. If they have secure things in them, you can also download those from S3. And so to do this in the template, there's two pieces. The first is the AWS CloudFormation authentication piece. So you can see here we've just defined a role creds object that's of S3 type, and it points to the role name, my S3 role. If you've created the IAM role in your template, this is going to become a ref, and you'll just ref the role that you created. And then we have a file called secrets.txt that nobody will ever try to look into, and we're going to download that from S3. And you can see there's an authentication key pointing at role creds. So anytime we try to download this file, we'll sign that with the IAM role you provided. I also wanted to touch on CFN Hub. It's been there since the beginning, installed with CFN init, but we don't use it very much in the sample templates. It's available as a service on Linux and Windows, so it actually runs as a daemon. And it listens for changes to your CloudFormation stack and runs scripts when those changes happen. So you'd say, whenever the metadata is updated on my EC2 instance, rerun CFN init would be a common use case for CFN Hub. And you might be thinking, that sounds a lot like a custom resource. And it is. A custom resource does require an SNS topic and usually an SQSQ, so there's a higher barrier to entry there. But CFN Hub doesn't have nearly as many features as a custom resource. So CFN Hub can't interact with CloudFormation whatsoever. It's just a listener. So the workflow is not going to wait for CFN Hub to be done. If CFN Hub crashes and burns and fails miserably, the CloudFormation workflow will say, update complete, I'm done. And you can't pass data back into the stack from CFN Hub. So it's really like just starting a new thread and running that thread and ignoring the result. And that's pretty much it for today. So hopefully you learned a little bit about custom resources and how they let you extend CloudFormation, and a little bit about what we've added to CFN init recently. We'll be available for questions now, and I'm going to be working the booth in reInvent Central tomorrow morning, and we'll try to be available at the Dev Lounge. So since there's a lot of Amazonians around, you can take a picture of our faces and compare us to everybody you see, and hopefully you'll find us eventually. So feedback's really important. There's places to leave feedback set up all around. So this is, again, DMG 303, CloudFormation under the hood. We really look forward to it, both positive and negative. And we'll take questions at the mic now. Thanks.